Hello students, today we will discuss about the equilibrium. In that equilibrium, in the last class we have did the one problem on the determining the Kp and Kci. We will move on to the next problem here. There is the problem second. Problem number 2. 1 mole of H2O, 1 mole of H2O and 1 mole of CO and 1 mole of CO are taken in 10 liter vessel, are taken in 10 liter vessel and heated to 725 Kelvin at equilibrium 40% of water, 40% of water bracket item here by mass reacts with CO, carbon monoxide, according to the equation H2O in the form of gaseous form plus CO, it is in the form of gaseous form. When they react with here water, when it reacts with the carbon monoxide, so it gives what? So it gives the hydrogen, and plus CO2, both are there in the form of what? Gases. Okay. Calculate the equilibrium constant for the reaction. Equilibrium constant for the reaction. You see here, this is the what problem is there here. You see on the board here, that is the problem. What they are asking here, 1 mole of H2 is there here, 1 mole of H2O and 1 mole of carbon monoxide is there. 1 mole of carbon monoxide, CO, are taken in what? That is, they are taking what? H2O. 1 mole of H2 is there and 1 mole of carbon monoxide is there. They are taking in what? They are taking in a 10 liter of vessel. 10 liter vessel is there here and heated to what? At 725 Kelvin. Okay. First they are what taking here? First you have to understand that one. You have to understand the problem here. How we have to understand here means we have to take a vessel. This is the one vessel is there. Consider one vessel is there. So in that vessel, what we have to take here? We have to take 1 mole of H2O. That is the 1 mole of H2O I have taken here. H2O plus what we have to take here? 1 mole of carbon monoxide we have to take. 1 mole of carbon monoxide I have taken here. 1 mole of carbon monoxide. Next, in a 10 liter vessel is there. This vessel is capacity is what? 10 liter is there. 10 liter vessel is there here. In the 10 liter vessel, we have taken the 1 mole of H2O and 1 mole of carbon monoxide. Next, I am heated to 725 Kelvin. it is getting, we have to heat this one into water at what? 725 Kelvin. 725 Kelvin. At equilibrium of 40% of water by mass react with the carbon monoxide. According to the equation, H2O is in the form of gas, CO is in the form of gas, react with it using hydrogen and carbon dioxide. Calculate the equilibrium constant for the reaction. They are telling you to find out the equilibrium constant, that is our Kc here. So here they are given the H2O, 1 mole of H2O, 1 mole of carbon dioxide. They are taken in a 10-liter vessel and it is get heated here. When it is get heated, what happens here? The 40% of water reacting with the carbon monoxide. Only 40% of water is reacting with the carbon monoxide. That you have to remember here. This is the very important point is there here. Okay. So then it gives equilibrium is attained here. When CO, H2O, it reacts with carbon monoxide, it gives what? Hydrogen and carbon dioxide. They are telling for us to calculate what? For calculating the equilibrium constant. That is very important. Calculate equilibrium constant. Okay. Now the solution you have to take. That is, first we have to write out the reaction here. That is H2O is in the form of gaseous form. It reacts with carbon monoxide, which is also in the gaseous form. So it gives both sides. This is a reversible reaction. That it gives what? It gives H2, which is in the gaseous form. Plus CO2, it is also in the form of gaseous form. Okay. Next, what we will do, sir, here is at initial stage, initial, that is T is equal to 0. Initial what happens? We are taking the initial T equal to 0. So then what happens here? The concentration of the number of moles, you have written T is equal to 0. Number of moles. How many number of moles is there here? Nothing will be there here, means 1 is there means. So it is having what? Only 1 mole initially. Initially it is having the water is having the 1 mole. Next one, you see here carbon monoxide is there. Carbon monoxide initially how much mole is there here? No any number is there means 1 is there means. So it is also 1 number is there here. 1 mole is there. Water is also 1 mole. We are given number of moles. Initial T is equal to 0. What is the how many number of moles is there here? In the reactants, so water is 1 mole is there, carbon monoxide is 1 mole is there here. Next one, you see here hydrogen and carbon dioxide. They are not formed. First what happens? Reactant is there. Reactant, when they are reacting, then it gives the product. First initially it is not formed here. Means I have to take the initial number of moles is 0. Why you are taking such 0 here means? So they are not formed here. Okay. So because of that reason we are taking the initially they are 0. Initially product is not formed here. First reactant is coming. When the reactant combining, then it gives what? Product here. So because of initially I have taken here product number of moles will be 0, 0. Okay. Next one. Next one, at equilibrium. At what? Equilibrium. At equilibrium. When the equilibrium is attained here, the reactant is converted to product, product is also converted to reactant here. Then what happens here? Then here means the initially what happens here? 1 is there, 1 mole is there. When the reaction starts, what happens here? The concentration, reactant concentration always decreases. That I told in the last classes only. That always the reactant concentration is decreases and the product concentration will be increases. So because of that reason, I will take it as what? 1 minus x. How much it will decreases? X number it will be decreases. Because of that reason, 1 minus x I take here. Okay. For CO is also what happens here? CO is also decreases now. This is also one of the reactant. Okay. So then you have to take it for what? 1 minus x. Next one. Here what happens? Here in H2 what happens here? It will be increases here. Increases. First 0 is there. 0. Afterwards what happens here? The concentration will be increases. How much increases? The x number will be increases here. Products here. So here in the CO2 is also what happens here? The 0 plus x. This much number will be increases here. First 0 is there, then it will increases to plus x here. Here it will be decreases. That you have to remember in the rate or velocity of a reaction. That I had explained, that one is indicates that the rate of concentration of reactant will be decreases and the product will be always increasing. Okay. Next one. Next one. Here you have to write on here. That is the x is equal to what? According to the question. According to the question, what is there given? You see here, 40% of water by mass reacts with what? CO. That you have to remember here. So according to question, when is there x is equal to what? X is equal to, we have to take what? 40%. 40% of 40% is converted here. So here remember 40% of water is react with the CO and it gives what? So x is equal to 40%. It will 40% of 1 is equal to 0.4 moles. Why you taken sir here 40%, x is equal to 40% of 1? Why you taken sir here means x they are given here. How much amount of water is reacting with it? Water is reacted here. 40% of water at equilibrium, 40% of water reacts with CO. How much amount of water is reacting with CO here? 40% of hydrogen. Sorry, water it reacts with what? It reacts with CO is there here. Then you have to take 40% is equal to 1. 1 you have ever taken here means first initially how much moles is there here? 1 mole is there. Means 1 by 40. Sorry, when you are taking. So that is when you are taking 40% is there here means 1 mole is there. That 40% is there means what happens here? 40% means you have to take what? 0.4 moles. You have to take what? 0.4 moles here. Okay. Next we have found out what? 0.4 moles here. Next one, for find out in the Kc, this is very important that we have to find out the delta n value. First, delta n is equal to delta n means what? Number of product minus number of moles of gaseous product minus number of moles of gaseous reactant is there. So then you write down number of moles of product. How many is there here? Product here 1 mole is there. Here 1 mole is there. 2 is there here. Product is what? 2 is there. 2 minus. So here you see this one 1 is there. Here also 1 is there. Here also 1 is there. So 2 moles is there. So 2 minus 2 it will be equal to what? 0 is there. It will be equal to 0 is there. Means delta n the reading the value is 0 is there here. Next one you have to write down the Kc. Kc, what is the value there here Kc? So we are taking here 0 moles we have to find out at that one. 0 moles when you find out at here means then the 1 minus 0.4 when you are doing 1 minus x value find out at x is equal to what? 40% of 1 is equal to 0.4 moles are getting. So 1 is there here. 1 minus 0.4. What is the value you are getting? 0.6 mole is there. Okay. Next here also what happens here? 0.6 mole you are getting. Okay. Next in this side 0.4 only. Here also what happens here? 0.4 mole you will get. Okay. That one we are found. Next what happen here? That is the Kc. What is the Kc is there? That is the Kc is equal to C raised to C into D raised to D divided by A raised to A into B raised to B. That you have to calculate here. So here what happens? That product divided by reactant is there. Kc is equal to then H2 into CO2 divided by H2O into CO is there. That you have to write. Kc is equal to there is what? H2 is there. H2. So H2. So how many is there? H2 is there here. Hydrogen. That is your running water. How many mole is there here? 0.4 divided by 10 you have to take. Why you have to take sir 10? Here means there is the number of moles 0.4 divided by 10 you have to take. Why sir here means so that is you are taking in a what? 10 liter vessel. You are taking in a 10 liter vessel. That is a hydrogen and water and CO. You are taking in a what? 10 liter vessel. That you have to keep in your mind. The H2O and 1 mole of CO is taking in a 10 liter of vessel. Then what we have to make here means there is 0.4 divided by 10 you have to take. Plus into is there 0.4 divided by this also 10 becomes. 4 you have to divide by 10. Next one Here what happens here for H2O? How many moles is there? 0.6 moles are reacting here. Means that is what write down here what? 0.6 by 10 into 0.6 by 10. When you are solving this one, what is the value we are getting here means? What is the value we are getting here means? That is the Kc is equal to what? Kc is equal to that is the 0.44. So you are finding what? Equilibrium constant here. You are finding what? Equilibrium constant. Okay, I will explain once again here. So here first I have taken here H2O. The first I have done here reaction. First initial concentration, reactant side I have taken 1 mole. Number of moles I have written here. Number of moles 1 here. Product side it will not be here. Still it is not formed product. So because I have taken the number of moles will be 0 is there here. Next one at equilibrium what happens here? 1 minus x we have to do because x number of moles will be decreases. The reactant always decreases. So 1 minus x I have taken here. So here means 0 plus x and 0 plus x here the product concentration will be increases. Next one 0.6 mole. How we are taking 0.6 mole here means they are given only 40% of water is taken in what? Taken as a 1 year. 1 year taken 1 mole is there. 40% is reacting here means 40% is there. 1 in the 1 you are taking 40% here means so it becomes in 0.4 moles. That 0.4 moles divided by 10 you have to take. Why sir here means the 10 liter of vessel is there here. 0.10, 0.4 by 10, 0.4 by 10 in divided by 0.6 by 10 into 0.6 by 10. When you solve this one, you are getting what? You are getting the Kc value. Kc value is what? 0.44 is there here. Okay. Next one, we have to understand about the relationship between the Kp and Kc. Next one, that is the relationship between equilibrium constant, equilibrium constant. Next one, reaction quotient. Reaction quotient and Gibbs energy. And what? Gibbs energy. Relationship between the equilibrium constant and reaction quotient and Gibbs energy. What is the relation is there? The Gibbs energy already studied that one. Okay, the last class only. Here is the what? Equilibrium constant, reaction quotient and Gibbs energy. What is the relationship is there in between these here means? So first you have to write down here is what? The change in Gibbs energy. The change in Gibbs energy and the composition of reaction mixture of reaction of a reversible reaction is given by the equation is given by the equation. So you see here the change in the Gibbs energy and the composition of reaction mixtures of a reversible reaction is given by the equation. There is one equation is there here, that is the delta Z is equal to delta Z naught plus RT ln Q. So this is the what one reaction is there here. Delta Z is equal to delta G naught plus RT ln Q. So here what happens? So when you, what is the delta G naught is there, sir? Delta G means what? Gibbs energy is there. What is the meaning of delta G naught, sir? Here means the delta G naught is a standard free energy. Delta G naught is a standard free energy. Standard free energy. Standard free energy. Next one, when at equilibrium, that is I have written here reversible reaction is there. Reversible reaction is what? Here equilibrium is written here. At equilibrium, what happens here? At equilibrium, there is a delta G is equal to what? 0 here. That you have to write down. At equilibrium, what happens here? Gibbs energy becomes 0, and that Q is that Q becomes reaction coefficient. That becomes what? That becomes here Kc. At equilibrium, this is the reversible reaction is there. In the reversible reaction at equilibrium, what happens? Delta G becomes 0 and the Q reaction quotient becomes the equilibrium constant. Okay. Next, what happens here? When they are become 0 here means, so then the reaction becomes what? Delta Z naught equal to minus RT ln Kc. This is a very important one. This is also very important one here. So when the delta G is equal to 0 and Q is equal to Kc, then you are getting what? Delta Z naught is equal to minus RT ln Kc here. Okay. Next, so when you are this ln Kc, then this ln Kc, so when you are moving this one here, this side minus RT, then what happens here? What you are getting? Ln Kc is equal to what? Minus delta Z naught by RT. This is also very important equation is there. When the minus RT we are moving this side, then we become what? Ln Kc is equal to minus delta G naught by RT. So when you are taking natural logarithm on both sides, then this reaction becomes what? Then the Kc is equal to that is the e raised to minus delta Z naught by RT. When they taking the natural logarithm on both sides, this equation becomes what? Kc is equal to e raised to minus delta Z naught by RT. These are the very important equations are here for doing the when calculation the Gibbs energy. They are asking sometimes equilibrium constant. Then these terms are very useful here. So next one, what is the useful is there? Gibbs energy here. Here means that is if delta G when it is less than 0 is there, then what happens here? If it is less than 0 here means K is greater than 1. If K is greater than 1 is there means what happens here? The reaction is spontaneous. The reaction is what? Spontaneous. What is the meaning of spontaneous here? Means spontaneous means what here? The forward reaction is going on here. That in bracket or down. Forward reaction is going on. Suppose delta G naught is less than 0, then what happens? K is greater than 1. K is greater than 1 here means the reaction is spontaneous. Spontaneous means what? There is a forward reaction is taking place. Suppose if delta G naught is greater than 0, if delta G naught you have to use, so delta G is greater than 0, then what happens here? K is less than 1. Already you know that K is less than 1, K is greater than 1 is forward reaction, K is less than 1 is reverse reaction. So then the reaction is what? The reaction is reverse, sorry, the reaction is non-spontaneous. Non-spontaneous. Okay. Non-spontaneous is the means, so it will be reverse reaction. Reverse reaction. So this is about the what? That is the, you have to understand about the what? When the delta G is less than 0, then K will be greater than 1. If the K is greater than 1, the reaction is spontaneous, the forward is there. So here also delta G is greater than 0, then K is less than 1. K becomes less than 1. Then the reaction is not spontaneous, means it is a reversible reaction. Reversible reaction. Okay. Next one, we will do the one problem on this one. Gives free energy. Next one. Next one example. That the problem is there. Write on the problem. Okay. So here what happens? The problem number 1 in the relationship between Kc and reaction quotient and Gibbs energy that is given. Hydrolysis of sucrose gives sucrose plus H2O. Sucrose plus H2O, that is sucrose plus water. So it gives what? Glucose. Gives glucose plus fructose. Okay. Sucrose, when you are adding into the water, so it gives what? It splits into glucose plus fructose here. Next one. The equilibrium constant Kc for the reaction. Equilibrium constant Kc for the reaction. Kc for the reaction is 2 into 10 raised to 13. 2 into 10 raised to 13 at what? At 300 Kelvin. At 300 Kelvin. Calculate delta Z naught at 300 Kelvin. 300 Kelvin. Okay. First we have to understand that the question here. So here the question is what happens here. What is the question is there here? That is hydrolysis of sucrose gives sucrose when it reacts with water. So it gives what? Glucose plus fructose here. So equilibrium constant Kc for this reaction is 2 into 10 raised to 13 is there. Means they are given the equilibrium Kc, they are given here. Next one, at what? 300 Kelvin is there. So Kc at 300 Kelvin. Calculate delta G naught, standard free energy. Delta G naught means I have written in the class only, in this class only. That is delta G naught is equal to what? Standard free energy. Delta G is equal to Gibbs free energy. They are telling you to find out the delta G naught at 300 Kelvin here. Okay. In the question, they are given the Kc and also they are given what? That is the temperature they are given. They are telling us to find out what? Telling us to find out the calculate the delta G naught, standard Gibbs energy and at 300 Kelvin here. Then next we have to use the formula. What is the formula there? Delta Z naught is equal to minus RT ln Kc is there here. Okay. So this is the what? Write down the solution. Delta Z naught is equal to minus RT ln Kc. So they are given the Kc value, and also they are given what temperature they are given. R value gaseous constant value is 0.08831. That is the value is there. Okay. Then if you have filled that one here means you are getting the answer. So then next you write down delta Z naught is equal to there is a value you have to put here 0.0831 also you can take here. Suppose if they are here, you can also take it as what joules per mole kg. That if you are taking here means then you have to take it as what minus 8.314 joules per mole per Kelvin. Joules per mole per Kelvin into what temperature is what temperature they are given here. Temperature what is there here? Temperature 300 Kelvin into 300 into what? Into ln is there here. Ln. Next one Kc value. What is the Kc value is there here? The Kc value is what? 2 into 10 raised to 13 is there Kc value. That you have to know 2 into 10 raised to 13. 2 into 10 raised to 13. So what you have to do here means, so when you are calculating this one, when you multiply this one 8.314 into 300 and you are taking the logarithm value for this one 2 into 10 raised to 13, then you are getting the answer is what? Minus 7.64 into what? 10 raised to 14 joules per mole. So this is the what delta Z naught is equal to standard free energy we are calculated, that is the value is what minus 7.64 into 10 raised to 14 joules per mole. So on the next class onwards, what happens here, we have to know about the how to find out the logarithm values, that you have to learn.